Today now we will start with lesson 2, conservation of charge. Yesterday we said that any object has an equal numbers of electrons and charges. We said that the number of protons as the number of electrons. For helium, for oxygen, for hydrogen, so on. Any atom, the number of protons equal the number of electrons. But if the number of the protons are not equal to the numbers of electrons, I will say that this object or this atom is electrically charged. So if they are equal, there's no charge. If they are unequal, it is an electrically charged. So electrons and the protons have electric charge. That we said yesterday. The electrons is negative and the protons are positive. They are electric charge. In neutral atom, there are as many electrons as protons. That we said yesterday. So in one atom, we have the same number. In one atom, it's okay. It's right from here. So in one atom, we have the same number of protons and the same number of electrons. And both of them are electrically charged. Now, since they are equal, so there's no charge for the atom. The net charge is 0. Like they are plus 3, negative 3, like in math, they are canceling each other. So in atom, since the number of protons are equal the number of electrons, so I will say that there's no net charge. But if the numbers of electrons and protons are not equal, like I have 3 protons and 2 electrons. If the number of protons are greater than the number of protons, are greater than the number of electrons, I will say that this atom is positively charged. But if the number of electrons is greater than the number of protons, I will say that this atom is negatively charged. In neutral atom, in any case, the atom has the same number of protons and electrons. But if you make something with the protons, if you add the protons, if you remove protons, the number of protons and electrons now will not be equal. So there's a charge, there's an electrically charge. I will not say that the net charge is 0. So if an electron is removed from an atom, the atom is no longer neutral. It has one more positive charge than negative charge. Imagine that you have here a same, let's see now, imagine now that here we have this is the protons. In any atom, we have like 5 protons and as an example, 5 electrons. This atom now, and also we have neutrons, but I will not draw them here. Here now we have the same protons, the same number of protons, and the same number of electrons. Now, they told me that if you remove, imagine that now you remove 1 proton. So how many electrons do you have here? You have 5 electrons and 4 protons. Is it right?
Yes.
So
Yes.
if you remove now 1 proton,
Yes.
the number of electrons. So what happened now? The number, if you remove 1 proton, the number of electrons now is greater than the number of protons, because 5 is greater than 4. So because of that, if the number of electrons are greater than the number of protons, so the ion here is negatively charged. I will say now I have a negative ions. The negative ions, it has a net negative charge. It has gained more or one extra electrons. So I can remove 1 proton from here, or also I can, they have this proton here, also I can add 1 electron. If it is gained 1 electron, so since now, because of that, now we have a 6 number. So the answer here is, so the total number here is 6 for the electrons, and we have 5 protons. So the number of electrons are greater than the number of protons. So I will say that this is a negative ion. So if it has more than 1 negative charge, this atom, it will be charged, and I will say it is a negative ion. But if you now, let's make them now 5. If you now lost 1 electron, if you lost now 1 electron, so how many protons now? We have 5. And how many electrons now? We have 4. The number of protons now greater than the number of electrons. So if the number of protons greater than the number of electrons, I will say that now this is a positive, this ion is positively charged, because there's a net positive charge, it lost 1 or more electrons. So if the number of electrons, which is the negatively charged, is greater than the number of protons, I will say that is a negative ion. But if the number of protons are greater than the number of electrons, I will say that this is a positive ion. Now we say that atoms are made of electrons and protons, and a matter is made of atoms. So a matter is made of atoms, and the atoms are made of electrons and protons. What does it mean? That means everything you have, if as pencil, calculator, book, laptop, anything, any object, any matter, it has an electrons and the protons. Why? Because any matter is made from atoms. And these atoms, it contains electrons and protons. What does it mean? Like the balloon as an example. The balloon is an atom, is an matter, and it's made from electrons and protons. All of us know that if you have a balloon and you move the balloon, touch the balloon with your head, and what happened? You give a charge, you add proton, or you remove electron from the balloon. So the balloon now is charged. Since it's charged, if you put it on the wall, the balloon will stick with the ball. Why? Because the balloon now is charged. So, before that, before we touch it with our hair, the number of protons are equal to the number of electrons. But when you touch it, you add electrons to it. So it is negatively charged. As an example, when you put it on the wall, it sticks with the wall. Because like the wall is positive, the balloon is negative, they are now attracting to each other. So an object that has equal numbers of electrons or protons has no net electric charge. But if there's an imbalance in this number, the object is electrically charged, that we said before. An imbalance comes about by adding or removing electrons. So what does it mean? That means the protons are not moving, only the electrons are moving. So we can add electrons or remove electrons. When electrons are transferred from fur to the rod, as this picture here, look at here, he has a fur in his hand. He has a rod. When you touch the rod with the fur, okay, when you remove it, come back and up and back, right and left, all of these waves, you charge now the rod. Try it. Then after that, bring a pieces of paper. Touch the paper with this rod. It will attract it like the magnetic. Why? Because you charged the rod. Since you charged the rod, you give a rod an electrons. Since you charge it, you can touch now the paper. So the rod now becomes negatively charged, and as an example, the paper has all positive charge. They are attract to each other. So look here, I said electrons transferred. Now this lead to me to talk about the principle of conservation of charge, like the principle of conservation of energy. Electrons are neither created nor destroyed, but are simply transferred from one material to another. What does it mean? That means if there's an atom here and there's another atom here, if we have 5 electrons and here we have 6 electrons, if you give 1 electron to this to the second atom, here you will have 4 and here we will have 7. So exact 1 electron is transferred to the second atom. There's no created. What does it mean? That means I will not give him 1 and they receive 2. Or I not give him 1, they receive 0.5 or 0. Electrons are neither created nor destroyed, but are simply transferred from one material to another. This is like the conservation of charge. This principle is known as conservation of charge. Sorry, it's like the conservation of energy. In every event, whether large scale or at the atomic or nuclear level, the principle of conservation of charge applies. An object that is electrically charged has an excess or deficiency of some whole numbers of electrons. What does it mean? That means the electrons cannot be divided into fractions of electrons. I cannot say 1.5 electron or half of electron. It must be whole number. 1 electrons, 2 electrons, 3 electrons, 10 electrons. So what does it mean? That means the charge of the object is a whole number multiple of the charge of an electron. I mean that now the charge of electron, sorry, The charge of electron is 1.6 times 10 to the negative 19. This is the charge of electron. So the charge of electrons is 1.6 times 10 to the negative 19. Now, they told me that the number of electrons are what? Are whole numbers. So here, if you come back here, what did we say before? We said before that means the charge of an object is a whole number multiple of the charge of an electron. The charge of the object is a whole number multiple of a charge of electrons. That means this is the charge of electrons. Now, the number of electrons, as I told you, it must be whole number. Like 6 as an example, 5, 4, and so on. So the total charge, it will be the number of electrons times the electron charge. That's mean if the numbers of electrons are 7 or are 6 as an example, and the charge of the electron is 1.6. So I will multiply now 6 times 1.6 times 10 to the negative 19. After you multiply them, you get the total charge is 9.6 times 10 to the negative 19. Later on, you will say that the unit is coulomb. So the total charge here is 9.6 times 10 to the negative 19. As you see, it is a whole number. Well, how, the teacher, it is 9.6. Yes, you can write it as 96 times 10 at, make it 10, so it will be negative 90. So that's why it is a whole number. As you see here, it's 96 times 10 to the power. Wait here, I made something wrong. Wait, okay.
Teacher,
Yes.
from where did we get the 6?
This is an example. But wait, I meant. يلا. I will repeat from here. So the number of electrons, okay, the number of electrons is the total charge over the electron of charge. So of the charge of one electron. So this is now the formula that we use. To know the number of electrons, we have to divide the total charge over the charge of by the charge of one electron. What does it mean? If the total charge is 2, this is an example, or 6, okay? Because it must be a whole number. If the total charge is 6 over the charge of one electron, as I told you, it is 1.6 times 10 to the power negative 19. So 1.6 times 10 to the power negative 19. So if the total charge is 6 and the charge of one electron is 1.6 times 10 to the negative 19, so the number of electrons, it will be 6 over 1.6, which is 3.75 times 10 to the power 19. Or you can say it's a 375 times 10 to the power 17. So that's I want to tell you about it. That the number of electrons, it must be a whole number. Why? Because the total charge is a whole number multiplied by the charge of one electron. So the number of electrons that will be transferred from one atom to another is a whole number multiplied by 10 to the power 19 or to the power 17 if you transfer it. So if I asked you how many electrons, okay, well, it's inshallah next lesson I will give you examples with the Coulomb's law. How many electrons will be transferred from one object to another if the total charge is 7? You tell me 7 over 1.6 times 10 to the negative 19. So you tell me that the number of electrons will be 3.75 times 10 to the power 19 electrons. Is it clear?
It is to the power negative 19 or to the